So we've defined objects and we've been using them, and I'd like to take a little look into how they're actually stored in the memory of a computer. So as a bit of review, recall that we use a stack to store the parameters coming into a method and also the return result from a method. So if I call a method foo and pass it the numbers 5 and 7, the 5 is pushed on the stack and then the 7, and when foo starts execution, it pulls those values off the stack, regards them as its local parameters, performs its computation, and then the result of the method is pushed onto the stack just before foo returns. Now this stack works really well for method calls, but the instance variables of an object are supposed to persist after all the methods have finished. So they can't live on the stack, they have to be stored in a more permanent kind of place. The place we store object instance variables is called the heap. Objects are allocated in the heap and they live there until they can no longer be referenced. It's not something we have to worry about as programmers because the runtime system for Java has something called garbage collection that comes along and collects up the unused storage the minute it can no longer be referenced. So let's take a look at an account object which has a single instance variable, namely its balance. When we create a new account, and let's say we put $100 into it, the reference to that new account is stored in the local variable account1. In the heap, an object is created. It's shown as a box here containing the value 100. Another way to think of this is that every location in the heap has an address, much like we have addresses on our houses on a street. And in this particular case, the address at which the heap value is allocated for this account object is at address 348. So the account reference, though we often draw it as a pointer, actually holds as its value the address at which the object is stored. We can view account1 therefore as having the value 348 inside of it, indicating that it references an object stored at location 348 in the heap. Suppose we allocate a second object, this time putting $50 into its balance. Java creates that object in the heap at a separate location. Let's suppose it's allocated at location 408, and each of the pointers from account 1 and account 2 are represented by their respective addresses at which their objects are stored. If we come along and add another instance variable to the account object, suppose we add an interest rate double to it, then we have to make room for that in the heap as well. And so starting at 348 in the heap, we find the balance of 100, but just after that we would find space allocated for the interest rate for that particular object. Now notice that each instance of an object has a separate way of remembering its balance and its interest rate because these can be different for each object we allocate. In fact, here we see account 1 has a balance of 100 with an interest rate of 0.05, while account 2 has a balance of 50 and an interest rate of 0.07. If we do add the instance variable interest rate to our account object, recall it's the obligation of a constructor to initialize the instance variables, and so we should provision for that by adding another parameter to the constructor to receive the interest rate at which this account should be instantiated and to remember it in the instance variable by assigning it. Or maybe we decide we're going to compute the interest rate from the initial balance, in which case the information would not have to be supplied as a parameter. These are issues of design in terms of how we want the object to be used, and it's really up to the designer and the programmer to coordinate how that contract is going to be fulfilled.